Yeah. Oh, by the way, class, I already put lesson 1 and 2 and 3 on YouTube. If you go to your class, bam, and you go here, you can actually just open up the playlist, and you'll see lesson 1.1, 1.2, and 1.3. Okay? So what I generally do, because I have 4 sections of this class, is I just find the one that I think is the best, the most comprehensive. Sometimes I miss things, sometimes I explain things better, different questions, whatever it may be. Sometimes the recording is just better. So I'll take the lesson that I think is the best one and I'll put it up, rather than just putting 4 sections because that gets confusing. All right, so that's up on YouTube. Now, first thing says, use interval notation to represent each number line graph. Okay, interval notation is the one with the parentheses and brackets. I have no beginning, so that's negative infinity. And then my endpoint is 2. Class, is that exclusive or inclusive? Inclusive, very good. All right, here my starting point is 0, so it starts at 0, exclusive, 3, inclusive. Any questions on that? Yes, ma'am. Oh, thank you. Appreciate that. Ends at -2. Any questions? No? Okay. Next one. Fill in the end behavior for each function. All right. Notice the notation. Notice that this notation exists before you do anything, right? It's not necessarily going to be that way on the test. I may just give you blanks and you're going to have to do it. By the way, the quiz, is going to just be 2 pages and then 50% multiple choice, 50% free response. Okay? So it's not going to be some super long quiz. It's going to be relatively short. Half free response, half multiple choice. Okay? Any questions on that? No? Okay. All right. As x goes to negative infinity, or for instance, I'm going to the left, what's my function doing, class? Increasing? Increasing without bounds. So that means it goes to positive infinity. And on the right, it's doing the same thing, so it also goes to positive infinity. On here, on this one, as I'm going to the left, my function is increasing or decreasing? Decreasing without bound. So there you go, and the same thing is true here. Class, what is this a graph of? That characteristic shape? What is that a graph of? It's 2 words, a something function. Abbreviated A. Go ahead. You're thinking about transformation, so I dig it. But it's AV. 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 Absolute value function. An absolute value function. Okay? Good. All right. Okay. Next. All right. So this is a really good one. I really like this one. Class, a hint. When I say to you, I really like something, it means pay attention. Inequality. So here, I've already got the set notation. It's asking me to write it in inequality notation. Well, it's the same thing, except just written differently. And the same thing is true going from inequality to set. I just write the x, and then -3 is less than x is less than 6. Okay? Here again, I have inequality. It wants me to write it in set notation. So it's x such that x is greater than or equal to -2. And then here, it includes -2 and goes to infinity. Okay? This is the only one that's actually like kind of, you got to come up with the inequality or the set notation. Well, x is in the middle, so you know x is in the middle, right? And then you draw these two. You say, well, it's 13, and it's inclusive, and it's 20, and it's exclusive. You see that? Makes it easier when you do that way. Do it that way. X here is in between these two things. Draw these. 13 inclusive, 20 exclusive. Okay, and then once you have that, you can go ahead and do the set notation relatively easily. Okay. Yes, sir. On the quiz? Well, it should be around 15, something like that. Okay. All right. Next. Any questions on this? No? Okay. Got you guys all hyped up in the morning. I was like, you guys were ready to go, and then it's like, it's okay. It happens. Just roll with it. You got to roll with it. All right. Next. Okay. This I'll leave to you, for you guys in your summer work. This is a good one. Okay. First, f of x is positive on the interval what? Now this is actually an interesting question because you might think it's always positive. But there's one point where it's not positive. What point is that? Can anybody tell me? At 0, at x equals 0. Because at x equals 0, it's 0, and 0 isn't positive. So how I'd write that is negative infinity to 0, exclusive, union 0 to positive infinity. You see that? Yes, ma'am. Right. It's not positive at 0, but it's positive everywhere else. So the way I write that is like this. Because basically this is saying negative infinity to 0, but it's not including 0, right? It's excluding 0. And it's positive from 0 to positive infinity, but it's not including 0 once again. Yes, ma'am?
But from the negative infinity to 0, that you have all of those negative numbers. So.
But the x values are negative. You're right there, sir. The x values are actually, you are right over there. The x values are negative, but the function is positive. For instance, here at negative 2, the function is equal to 2. So it's positive. The function is positive, not the x values. Does that make sense? Okay. Any questions? No? Okay. F of x has a 0 at where? X equals 0. Okay? It's increasing on the interval 0 to infinity, right? It's increasing from here to here. And it's decreasing on the interval negative infinity to 0. Okay? Yes, sir. Yeah. Sorry. It should be excluded. Because at 0, it's not increasing or decreasing. It's just flat. Right? Thanks, sir. And it has a local minimum of 0 at x equals 0. Here's my minimum point. Okay? Yes, sir. No. It's a parentheses. Sorry. Questions? Okay, number 2. F of x is positive on what interval? First off, is this function ever negative? No. No, never negative. So, is it always positive? Yeah, sure is. Negative infinity to positive infinity. It could be equal to 0 somewhere. I should have said, is it ever negative? No. Is it ever equal to 0 anywhere? It may look like it, but it's an asymptote, which means it's getting closer and closer to 0, but it never touches it. So f of x is negative on the interval. What I'll do right there is that. Does anyone know what that is a symbol for in math language? No solution or empty set. Okay? So empty set. Remember, we have set notation. If I'm saying empty set, it basically says there's no solution. Okay? You could just write no solution, right? That's fine with me. F of x has a 0 at x equals what? Anything? Is there ever a 0? No. So again, empty set. F of x is increasing on the interval what? Well, you may not be able to tell, but even right here, even though it looks like it's flat, it's actually slowly increasing. So it's always increasing from negative infinity to positive infinity, and it's never decreasing. Okay? Yes, ma'am.
What does it mean when it asks if the f of x has a 0?
F of x has a 0 when the function crosses the x-axis. For instance, if I were to have a function that looks like this, my 0 would be there. Okay? Any more questions on that? Yes, sir. I clearly haven't written the quiz yet, so I'm not 100% certain, but you can expect that anything that I'm going over today is fair game. Okay, and also anything that's been on your homework, and also like anything from the lesson, even things not from your homework. So here's a better question and a better answer. Not that it was a bad question. Your study materials are specifically everything that's in your book, which includes your homework, including homework problems that you didn't do, right? Okay, that's still a resource that you could practice with. Okay, one of the things, hey, if I left out that homework question on your homework, but it's a really good question, probably fair game for a quiz. Most likely on quizzes, I'll give you things that you've seen before, and on tests, I'll give you things that you haven't seen before. Does that make a little bit of sense? Yeah, kind of. Not that you haven't seen it before, you've seen the material, but not the exact question. Okay, but your study resources are those videos, your book, and anything that I talk about in a lecture. Okay. Beyond that, it would be hard for me to kind of give you something. Does that make sense? Okay. All right, next question. Okay, here, that one I'll let you guys do. And you can tell that it kind of tells you what to do on that page, which is really good. Okay, this one here. So basically, what this is going over is there's this Akron and Wellington, okay? And there are temperatures in Akron and temperatures in Wellington, and what they're showing is a relationship between the two. You can see as the Akron temperature goes up, the Wellington temperature goes down. All right? So as Akron gets warmer, Wellington gets colder. Okay, and that's a relationship. And that's modeled by this equation here, y equals negative 0.3175x plus 77.7326. Any questions on that? No? No questions? No? Yes? No? No? Everything going okay? What's on the next one? That's not funny. Okay. Now, all right. Use both equations to calculate Wellington's temperature when Akron is 65 degrees. Okay. If we look back here, we see Akron's temperature is our x, Wellington's temperature is our y. So if it's giving us our Akron temperature, what should I plug that in for? For x. Akron is x, Wellington is y. If I plug in Akron's temperature of 65 degrees, I should get Wellington's temperature. Does that make sense to you guys? You understanding? Okay. So I plug in 65. I'll do the quick math here. Negative 0.3175 times 65, and then plus 77.7326. I just plugged it in, and I got 57 degrees. Okay? So, now, I know you guys know how to plug things in. First off, on this quiz, you guys can bring your calculators, but you're not going to. You can have them sitting on your desk, but I'm fine with you having your calculator on your desk, but you're not going to need your calculator for this quiz. Anyway, the point is, you know how to plug a number into an equation. The difficult part for this was figuring out what was x and what was y, right? So you know which to plug in 65 into. And now it says, is this examples of interpolation or extrapolation? So the temperature was 65 degrees. Now extrapolation means that we're taking our data and we're going outside of our data. Interpolation means we're on the inside. Extrapolating is outside. Interpolating is inside. Does that make sense? So interpolation is in the inside. Well, hey, 65 degrees is right here. So that's inside, so that's interpolation. Does that make sense? It's not extrapolation. Extrapolation would be like, if Akron was 112 degrees, what would Wellington be? Okay? And generally speaking, in these kind of circumstances, interpolation is more accurate. Okay. Find the inverse of the function. You guys should be fairly well versed on this at this point. You guys remember the song?
Yes.
How's it go?
Change, flip, sulfur, now you gotta simplify.
Nice. Nice. Good job. Change, flip, sulfur, y. Now you gotta simplify. Do you want a mint? You earned one. Yes. It's a little fish mint. Aren't they cool? Right? Good. Change, flip, sulfur, y. Now you gotta simplify. Okay, so change it to y equals 2x plus 5. Flip it, x equals 2y plus 5. Solve for y. So subtract 5 from both sides. Bam. X minus 5 equals 2y. Divide by 2. Y equals x minus 5 over 2, or 1/2 x. This is simplifying. Minus 5/2. Okay? That's how you find an inverse. Any questions?
It can't be x minus 5 over 2. You have to simplify it into fractions.
Why do you think that's a good thing to simplify it into this form? Into this form specifically?
Because it shows the slope more clearly.
Yeah. It shows it in y equals mx plus b form. And then rather than looking at this and trying to figure out the slope and the y-intercept, I just have it right there. So my mind is more clear. Yes, good. Nicely done. Actually, not f of x, but f of no, you got it. F inverse of x, right? Good job. Thank you. Good job. I like it when I get corrected or like someone's like, hey, you forgot this part. I'm just like, yes. Means you guys are learning. Any questions? Okay. Next. Find the ordered pairs of the inverse function, graph the function and its inverse. Okay. All right. We flip x and y, so 1, 5 becomes 5, 1. 2, 2 stays 2, 2. 3, negative 1 becomes negative 1, 3. Okay. I'm going to graph the inverse in red. So, and the regular function in black. So the regular function is 1, 5, 2, 2, 3, negative 1. And I'll go ahead and plot that line as much as I can. And then we have 5, 1, 2, 2, and negative 1, 3. And there you go. Any questions on that? Okay. All right, let's move forward. Yes? Go ahead. Okay. All right, this I'll let you do on your own. This I'll let you do on your own. And then we come to this, and this will be the last thing that we will do. Okay, so here's what I want you guys to do, so your brains get cranky because I've been doing all the work for you today. Do numbers 1, 2, 3, 5, and 6. Yes, sir. If anyone needs to use the restroom now, you can go ahead and use the restroom. But do 1, 2, 3, 5, and 6. Yes, sir. Oh. Did you hand in a packet to me?
No, I just need that one because
No. I didn't actually hand them out.
Oh,
I just handed them back to people that came in.
Is it what we're doing right now?
Yes. Also, summer work. Guys, to be clear, you can hand in your summer work to me tomorrow to receive full credit. Okay? You can hand it in to me tomorrow to receive full credit. Also, that happened with like 5 people in this class, for whatever reason, received a 0. Also, class, while I'm on that subject, I just want to show you guys, don't necessarily look too much at people's grades right now, but I just want to show you guys something so you can understand. Well, why isn't it showing up now? Oh. So, well, that's interesting. Now nobody's grades are savage. Okay, so look, we've gone through 1 week, and those are the grades, right? Now, the point is, look how many grades we've got, and I've got 100 kids in integrated math this year. You guys got to be responsible for checking the grade book and seeing if I made an error, okay? So that means when you're doing your homework, you should write down, like I said to you, I got a 4, and if I accidentally put in the grade book that you got a 3, you got to let me know. I'm all about just trusting you guys. I trust you at your word. Like, there was a mistake that I made where a bunch of people ended up getting 0s when they shouldn't have, including Mr. Day here. So anyway, the point is that you got to make sure that you're doing your due diligence and checking your grades. Is that clear? On my CCA. And that'll help me. Okay. Any questions about that? Oh. What happened to Matthew? Okay. So Matthew and Casey, both of you guys, what happened to? So you guys should be working on it. Oh, sorry. Some of you don't have the packet. 1 through 3, 5, and 6. Sorry about that, guys.
domain, then so
Okay. All right. Yes, ma'am.
like it's always from the same thing. Like it's the sign. Because I look at it from X, like I go from X to like I don't do it from left to right. Oh yeah, I go from middle to right.
All right. I'm going to go over it because we're running out of time. So, what is the domain of the function? What is the domain of the function? Well, the domain of the function goes from negative infinity to positive infinity. So that's negative infinity to positive infinity, and then you'd have to do it in inequality notation, and then set notation, which is like this. Right, the range of the function. Now, the range, it goes from negative infinity is less than x is greater than or equal to, or is less than or equal to 4. Now, remember, your bigger number is always on the right and your smaller number is always on the left, just like on a number line. Okay? And then I could write that as inequality. Yes, ma'am?
How come it's not negative infinity, positive infinity? Because the arrows are going down.
Because for the range, that's your thinking and behavior. The range, it starts at negative infinity and goes up to positive 4. End behavior is the next one, where it's both negative and infinity.
Why is the second one positive for domain?
Because for domain, I'm going like this. It starts at negative infinity and ends at positive infinity. You see? Domain, I'm going left to right, and it continues on forever. But range, I'm going bottom to top, and it stops here. You see? Oh, really? Okay, we'll have to talk afterwards. Okay, describe the end behavior of the function as x goes to negative infinity, as x goes to positive infinity. F of x, as I'm going to the left, the function goes to negative infinity, and as I'm going to the right, the function's going to negative infinity as well. It's going down on both sides. Okay? And then, sorry. What was that? Yeah. I'm not going to do that though right now because that's not going to be on the quiz. Okay. Thank you though. Okay. A student reads 3 pages of a book every 3 minutes for 1 hour. Every 5 minutes. 3 pages of a book every 5 minutes. So his rate is 3 pages every 5 minutes. And that's our function. F of t is equal to 3 pages every 5 minutes multiplied by time. And time is in minutes, not hours. So determine a domain for the situation, identify the range. The domain is obviously going to be starting at 0 and ends at 60 minutes. And the range, he starts with reading 0 pages, and then 60 divided by 5 is 12 times 3 is 36. Okay, I know I'm going super fast. Please forgive me for this. Okay. First, I'm doing the function, and then I get the domain and the range. Okay. This last one. Is the function increasing on each of the following intervals? From 0 to 2, is it increasing, class? Yes. From 2 to 6, increasing or decreasing? Decreasing, so it's not increasing, so no. 6 to 10, is it increasing? Yes. Okay. Now, let me just take a step back to go over this one because I rushed through it. A student reads 3 pages of book every 5 minutes. So the rate is 3 pages over 5 minutes. Okay? He reads for 1 hour. Write a function that models the situation. The function is the rate times time. All right? But the thing is, I can't use time in hours because my rate is in terms of minutes. Does that make sense? And then to get my domain, it's just 0 to 60 minutes, and my range is 0 pages to the total amount of pages he reads. So I do 60 times 3 over 5. Is that clear? Yeah, I hope so. All right, sorry about the kind of rush here today, class. Thank you for your understanding. Remember, you guys have a quiz. I will be here after school. If you need help, come see me in my office after school.
Where's your office?
No. Yeah. Just give me more room. Yes. Okay. So, as always, it's always going to be on my CCA.